I'm doing a presentation about Microsoft Fabric real-time analytics, and we are going to cross the streams, the data screens, of course. My name is Sander van der Velde. I'm from the Netherlands, and Sander is short for Alexander. I'm a Microsoft MVP already for 7 years now, and still counting, and I do mainly Azure IoT, Internet of Things. But I'm also a senior IoT architect at Alten, the Netherlands, where I provide real-time insights and analytics for customers based on the data coming from their machines, buildings, factories, vehicles, you name it, we can connect it. And there are a couple of links in here on this page where you can try to contact me. Well, there have been already a number of presentations about Microsoft Fabric. Today I will talk and show you how you can do real-time analytics and even trigger actions based on incoming data. Data incoming as a stream, not persisted or in batches, but as a stream. And maybe you're thinking, why is that important? Because, well, if it comes in every 1 hour as a batch, that's also streaming. Well, we are thinking about incoming events, data based on second or even sub-second level. Because these are real-time facts. They are mostly immutable, and they are observations from something that's happening. And that is more and more being combined with already persistent data. So think about log data, log analytics, or security audits, or of course, the stuff that I do, IoT analytics. It's all based on telemetry, and there's value in there. And luckily for me, Microsoft Fabric also has a real-time component in there. And that's basically focused on these 4 areas, these 4 items. That's the KQL database for storing real-time TimeSeries data, a query set where you can store and persist and share your queries. Then we have the event stream, where we can work with incoming data as a stream in multiple ways. And then last but not least, there's the data activator, where we can start building a trigger based on the incoming data when something is happening and we are interested in that. So let's cross the streams with Microsoft Fabric. And we start with the KQL database. It's a TimeSeries database, and we will look at it together with the query set. So the KQL database is a very straightforward database. It is based on TimeSeries formatted tables. So they are optimized for time related facts. And you can add tables, functions, materialized views, and even update policies, so you can create some flowing of data through the database. It's if you're aware of Azure Data Explorer, if you work with that, it will look familiar because this is based on Azure Data Explorer. So you can expect an insert-only table. You can scale from gigabytes to petabytes or even more, and partitioning and indexing of the data and even compression is done for you automatically. And the same goes for the scaling part of the database. But keep in mind, the data that you collect, although it's compressed, it is stored outside it's stored inside your capacity, but the costs are added to the capacity costs. And well, once you have that data, you want to query it. And for that, we use a KQL query set. KQL is the Custo query language. That's the query language which we will use. And you can take your best queries and turn them together in a query set, which you can share with somebody else And this looks a little bit like the Azure Data Explorer query editor. And that means you can even do some charting and rendering, and you can export the data to CSV. So let's look at this in action. And of course, we start at the start point of every Microsoft Fabric solution. That's the home page. And there we see a number of experiences. All these experiences will end up in the same portal, but with a certain focus on, well, advertisement of certain items in Fabric. And in this case, I choose the real-time analytics experience. And there you see the KQL database, the query set, and the event stream being advertised. Well, we need to work within a workspace. So I already prepared a workspace for us. And there we can create a number of items, not only the real-time parts, but that's just the advertisement. We can actually add everything we want. And as you can see, that segmentation or the categories is still there. But let's go for a KQL database. So let me take some copy-paste stuff. And I create a KQL database, which is called KQL database on capacity. And as seen in the keynote, this is created within seconds. That 5-second rule that they had. Here we have the database. It's already there. There are no tables in there, but you see everything is put in place, and we can start getting data. That can be data coming from, for example, an Azure storage account, or outside Azure from a S3 bucket. But it can, that's a one-time ingestion, but you can also work with continuous ingestion, like the event stream, which we will see later on. But for now, let's go easy, and I take a sample. There are a number of sample data sets, and I go for the log analytics, which is a data set based on events or areas of interest on a database. And it's related to the database that you choose and the machine information. And as you can see, the data is already ingested in a moment. And there we have it. It is 240 megabytes in size, but due to the compression, which is automatically done, you only have to pay for 18 megabytes. And that also means that there's less disk I/O needed, and the information is faster available. The columns of this table, because it's the logs table, the columns is that there's a name. That's the kind of message we have. The field is a dynamic column. That means a piece of JSON, which we can use in our query directly. And it's information about that topic. And then there are tags, that's the machine information. And there's, of course, a timestamp involved. No TimeSeries data without a timestamp. So that's what we have. And we can query it. And I prepared a number of queries in advance. So let me put that here. And this is a little query area. But keep in mind, this is not saved. So when I go back, I close the browser, I go away and I come back, this will probably be erased. But first we go for a count. And how is a count done? This is the custom query language. We start on the first line with a set of data, the table in this case. And on the next line we say with the pipe sign, I want to have a count. And that brings us one row with 618,000-ish rows, which is the same as what is seen over here. And then we take a random 100 rows. So we start with the logs table and we say take 100. And there it is. We have 100 rows of data just randomly picked. There's also a order by, but I show the take 100 because that's how we normally do. We first look at the size, then we look at a row, and we try to figure out how the data looks like. So there's a field, which is in this case server properties. These are the properties of that server, and the text says it's this database on this host. So then I think, well, maybe I want to have a distinct on the name. That's the kind of message, the database name and the host name. And I can even order that. And then we see that I get a distinct within a tenth of a second, well, eighth of a second, sixth of a second, over 600,000 rows. And we see that there is a distinct from wait stats on this database, on this host. And there's also a wait stats on this database on the same host, it seems. So that's interesting. Well, just to raise the bar, let's do a render. We can render this in a time chart. And that's done with, well, I take a certain message, I extend from the text, that's so a JSON part. I can say text dot, and that's a JSON column of the message, of the element. For there I can filter again, and then I order by, and then I only take 2 columns with the project. It's like a select wait time timestamp from a SQL statement, and that gives me 2 columns. So if I do render again, we have a render chart, which is nice. But keep in mind, if I leave this page, it will be removed. So we save it in a query set because I'm pretty proud about it. And it's the logs query set. And that brings me into a new page showing the same queries. And this looks familiar for those working with Azure Data Explorer, and we see the same rendering. But there's more. We can also say, okay, based on this information, I want to build a Power BI report. So let's do that. And there's a button there for starting up. With a little bit of luck, it's loading, and we get the familiar Power BI editor, where I say, okay, I want to have a line chart. Let's resize this a little bit. And because I had the cursor on the last query, I get the same columns. So I put the timestamp on the X, and I put the wait time on the Y, and there it is. The same chart is shown now as a Power BI report. So let's save this one also. And that is the logs report. And I have to choose the right workspace, and I say continue. And now it's saved. So let's go to the workspace. I already see the query set in here. I have to refresh this. And there we have the report. So if I do log report, I open it, and we see the same report. So that feels, well, quite familiar, I think. So let's go back to the presentation. What we've seen is the KQL database and the query set, and even the Power BI part next to it. But this is static data. We want to work with a stream, and that can be done with the event stream item. It's a no-code editor. It's just drag and drop, and we select one or more sources, which could be an IT hub or a event hub, or they're more, and you route the data towards a destination, which is, for example, a KQL database or a lakehouse. The reflex, we will see that one later on. And meanwhile, while the data flows through the event stream, you can add a event processor, which makes it possible to transform the data before you output it to the destination. Keep in mind that running an event stream takes a little part of your capacity. So you have to make a little bit of a reservation in your mind about how much CPU capacity units you need for your event streams. It's in the documentation, but it's recommended to have at least an F4 if you want to play with this. Otherwise, you will get some troubling. So let's do a event stream demonstration. And we just go back to our workspace. And in the workspace, we can do new event stream, and a name has to be given in, and call it the bicycle event stream, because we are going to do something with bicycle information. And for those familiar with Azure Stream Analytics, well, it helps because it will be quite familiar. It works with a source. There are a number of sources available, for example, an Azure IT Stream Hub, which is very interesting for me. But you can also work with a event hub, which is already there in Azure. I go for a sample one. So I make a sample source, and there are a number of sample streams made available. I go for the bicycles. And the bicycle stream is basically a stream which brings me every few seconds information about bike stations where people can rent a bike or they can drop off a bike. And in this case, it's in London. So if I go for the data preview, we already see that we get some data in from Chelsea and West Chelsea, with a street and a latitude, longitude, the number of bikes and the number of empty docks. That data has to be sent to a destination, and we go for a KQL destination. So if I do here, I've selected a KQL destinations. I could have chosen direct ingestion, but I want to add a event processor. The button is not available here because I have to fill all the other information in first. KQL destination. Well, and I choose the demo workspace because that's the database that we just created. And I want to create a new table. That's the bicycles stations, I believe. Let me check my. Yeah, that's correct. And yeah, it's in JSON format. And we open the event processor before we start this. And as you can see, here's the source, here's the destination, and I can do a number of operations like aggregations, grouping by over time, every 1 minute, every 5 minutes, something like that. So this looks familiar for people who have worked with Azure Stream Analytics, but I go for a filter. I could choose here a filter, but there's a new way to do that, and that's just filter. And now it's put in the middle. And we go to look for those bike stations which are in Chelsea, the Chelsea neighborhood. So equals Chelsea. And I say done. And I save it and I add it. And now the table will be created. The connection from the Stream Analytics to the table is created for us, and the filtered stream will start. And this takes a little moment. Are there any questions? I'm looking at the chat right now. Richard, are there any questions?
We don't have any questions in the chat, but if people want to have a think and post something now would be a good time while we have a little wait.
Yeah,
I've never seen an event filter working, to be honest. So this is really eye-opening for me as well.
okay. Well, that's nice to hear. And yeah, with a little bit of luck, it will work in a couple of seconds. This is not the 5-second rule that they advertise it, but it's still fast. I cannot do this with platform as a service stuff by hand. Meanwhile, I want to show something else because I know this is a little bit of waiting. What we see now, what I demonstrate now, is not the final solution. As you know, Microsoft Fabric is still growing and growing and growing, and they have a release plan page. And if you look at that, there's this time I look at the real-time analytics part, and there's beautiful stuff coming up. For example, a real-time dashboard. That's something that Azure Data Explorer already has where you get your data and it will over time change, and you will see the real-time changes of the data and the queries, the query outcomes. If you want to do something with SQL, you're not that fond of the custom query language, you can work with native support. What's not there yet is that we can pause and start and restart and stop a event flow. Once it is started, it's there. And what I also like, and that's for me, Microsoft has a new event grid capability for MQTT communication, which is a nice new IoT solution for devices who do basic MQTT. And there are more, but let me check if this is working. A few moment more. At this moment, we cannot ingest that much stuff, that much messages, but it scale up to 100 megabytes per second soon in first quarter. Well, this is already almost started, but if I look to the date in the database, I know for sure that there's already a bicycle station, and there it is. We see the table, we see the columns, and actually there's already some data in here. So that's perfect, because also for here I created a number of and it's the bicycle stations count. What did I do wrong? Bicycle. Oh, there should have been an S in there. Okay. So yes, at this moment I have 11 rows, because that demo stream, it creates events over time, and it has to start up a little bit. Later on it will pick up faster. Well, let's take a look at it, and we see only messages coming from Chelsea, and not the other Chelsea which we've seen in the before. So if we know that there are bike stations, let's enhance a little bit the empty docks. Those bike stations which have empty docks available over the last 1 minute. And if I do that, here we see that I have already 2 measurement points over the last few minutes. And these are the number of, well, you see this one has a lot of empty spots at this moment. So if I do another one where I want to have this made more visual, we can look at a chart, and we can try to figure out how many empty spots there are at this moment. So this is quite powerful, I think. This is really nice. If we go back to the event stream, we will see that the data is arriving. Here are the places, but actual outputted data is only for Chelsea. And you see the ingestion is now up and running over here. I was hoping to see some data, but also we get some statistics about the amount of bytes that are going through this stream. And we can even look at the possible throttling, because here we see the outputs, and with the data inside, we see that the filter is working. There are less messages sent than there are arrived, and we see a watermark delay. That's the moment of the time between ingesting and egress, and that's 4 seconds, which is quite fair. So that's most of the stuff that you need to know about event stream before you can can work with it. But now we only have a stream of data flowing in and coming in, and it's sent to a KQL database. What if we want to react on that data? There are certain conditions and we want to have an email, for example. Well, for that, there's a data activator. And there we can build triggers which alert you and me on certain conditions when the data is arriving. And you don't have to write any code. It's also done in the UI, and it works quite well. The data can be ingested from event stream, but you can also work with Power BI for that. If you have some data flowing through Power BI, it can be used for real-time triggering. And the actions that we can do is sending an email, we can post something on the Teams channel, or we can even send messages towards a Power Automate flow. So let's look at this also. And let's see if we can react on the data. Well, I'm back in the event stream, and there we can add a reflex. So I reflex destination. And that's the way to hand data over to the data activator. I have to fill in a workspace, and I have to give it a name because there's no reflex yet. You can add multiple streams and send them to the same reflex, but in this case, I create a new one. So that is the bicycles reflex. I always have that song from Duran Duran in my head. The reflex. Okay. Keep in mind there is no way to manipulate the data before it is sent to the reflex. In the KQL destination. In the KQL destination, we had the event processor, but the event processor is at this moment only available for KQL database destinations and the Lakehouse destination. So it will arrive probably soon. And now we see the data coming in towards the reflex. So I can open it, and we will see that the data is arriving. Every few seconds, we get a new rows, and then they are turned into green, and we see something like 40 messages, I think, per 5 minutes. And this line, it grows a little bit because, well, every few seconds, new lines are coming in. If you have multiple event streams, they will be listed on the left. You can get data from Power BI. Here's a little tutorial, small tutorial on how that's working. And there's also a simulation that you can run if you want to play with this without any physical streams available. So, but okay, this is the incoming data, and we want to have a trigger on that one. But for that, we have to go to the left lower corner for the designer. But the designer said, no, you cannot start designing a trigger because we need an object. And that's just a bicycle station. That's my object. And in the object, I say, okay, each bicycle station has a certain key. That's the bike point ID. And I can add properties to it. So let's add all the properties. And this is the object, because with this object, we can do some investigation on the real-time data, and we can start building a trigger if we want to. So I save it, and then I have created my object. And as you can see, I could also have it assigned to an existing object, because data from multiple streams, if they are related, if they're having the same key, then you can add them to one object. Now I go to the designer, and we get a designer, and we actually see already that there are some data coming in. These are moments that for certain bike points, that's why we had to give in that key. For certain bike points, we got some data. So let me add some data. As you can see, it's a little bit with a line. So the generator behind this is just creating some random information, typically for each bike point after each other. So this is the data that's flowing in. Here we have the object, the bike station, and there's no trigger yet. And a bike station has a number of properties. But we can also build our own property. Let's do that first. So I create a property which is based on a bike, number of bikes, this the number of bikes made available, and we see some measurements of the number of bikes for these selected bike stations. But we can add a filter, because I'm interested in the bike stations with a lot of bikes available. That's not efficient. So I want to have something like, well, at least 10 bikes must be there. So the property will be something like too many bicycles. And now I have created my own property. I can even add a summarize, a sum over, say, 3 minutes. And here we see that there's some measurements about the outliers. These two are really having too much bikes made available, because I take the sum over 10 minutes. Oh, wait a minute. I take this one over, say, 1 minute. That's why it was so high. So it's fluctuating a little bit. Okay, this is great. We have created a new property, but we are interested in those triggers. So we can also add a new trigger. And that's what we're going to do now. And a trigger is a combination of selecting one column, comparing it with a certain value, or well, something that to detect a certain condition, and then we act on it by, for example, sending an email. So first we select a column. That's the number of bikes in this case. And again, I could have added the filter stuff, but for now, this is the values that we're interested in. And then we do a logical comparison with true and false if needed, but in this case, I'm going for numeric. So I could have done something like if is greater than, but that means every time if a message comes in and the number of bikes is greater than, say, 10, I get an email. Well, that's a little bit too much, but I can also do become greater than. So that's the first time that it becomes greater than a certain value. And as long as it keeps that above that threshold, I don't get a new message. So you probably have to add a second trigger when it goes below that threshold. So in this case, I'm interested in something like becomes greater than 10, and that for a number of minutes. Try to figure out if we see some Here, for example, this is a situation that we had a buy point with the number of bicycles higher than 10, greater than 10, for at least 1 minute. So that could have been an email. That could have been a Teams channel item or a Power Automate flow being executed. So now we know it works as expected, and we go for an email. In this case, you can see email, Teams message, and custom action. I go for email, and I have a subject trigger, and the headline will be something like to and the bikes, and the optional message is please relocate. And I can also add a number of columns, like the neighborhood, the number of bikes that we've seen, and the street. So that should be enough if a message comes in that we are interested in this kind of information. I can save it and I can start it, but I'm a little bit lazy, and so I do a test message alert, and then I get an alert. But that takes a couple of minutes, so I prepared one already a few days ago, and here we see this is the message that we get, an email with the title and the action that we had that we have to do. That's the text that I just can fill in, and we get the columns like the bike station, the street, number of bikes, and neighborhood. This is the key that's added by default. So now we have a trigger solution. One more thing, you've seen that this one is grayed out, custom actions. That's because we first have to create a custom action. And what's that? It's nothing more than creating an endpoint which can be consumed in Power Automate. Power Automate has a connection and actions. And then with the connection, you can create a connection towards this endpoint. And once that is created, data will come in, and you can add extra actions on top of that. Keep in mind that you need a premium Power Automate account, because the connection that we are going to use is a premium connection. Okay, so this is the current state of the data activator. I was hoping for showing that we can compare the number of bikes with the number of empty docks, compared to columns, or seeing the percentages. I have twice as much bikes available as there are empty docks available, something like that, or some anomaly detection. It's not there yet, so probably it will come sooner or later, but that would make the data activator even more useful for us. So now we've seen the data activator, but okay, I'm doing IoT, so I also want to show you how we can ingest data from the Azure Event Grid, that entity broker. Officially, that connection is not there, but it can be done. And that I will demonstrate that because I did a little trick. I have a device over here on the left, and if you look at my head, it will turn into this device because it's running here on my desk. There's a energy master which can measure currents, voltages, and leaking away energy. And there's a little device next to it which has some compute. Actually, it runs a Node-RED container, and with Node-RED I'm communicating to the cloud, and that's the Event Grid namespace with MQTT support in the middle. Let me switch back. And every message that comes in is sent to an event grid topic in Azure. And from there, I've written a little piece of code to talk to an event stream directly. Can that be done? Yes, that can be done. And from there, well, the rest is stuff that you already seen, a KQL database and a query set. So let's look at the incoming data. For that, we move over to this page. Here we see the event grid namespace, and it has an MQTT broker. This is the MQTT endpoint. And we see a number of messages coming in from our power station. And actually, we see that it is also forwarded to a webhook. And here's the message that comes in. And actually, if I go into the webhook, which is an Azure function, I've written a little piece of code that calls our custom app. If I clear this, probably in a few seconds, some messages will come in. So because I can run an event hub inside the event stream. And let me show that, because it's running over here. This is a other event stream. Here we have a so-called custom app. You can see there's a custom app, but it's nothing more than a event hub which can be called, and it's running inside your capacity. So there's also support for MQTT or even Kafka if you want to ingest data from a sender, a producer, which has can connect to a Kafka endpoint. Here are the keys that you can provide, and the sample code even available already in Java, but with every programming language which can do Kafka or MQTT or Event Hub, you can make a call. And the data is flowing in from there to the KQL destination. But that's the KQL database. But in the workspace, I already created a KQL query set because I want to persist my calls, and I can do something like that. There are 3,500 lines in there at this moment. And the message that I get is from this device, a device ID, the key, the value, and a timestamp. And I can even order them. So I can look at the latest rows, and it's right about now. And we see the reactive current, the current and the voltage. And I can even do a chart on that one. So we see there's some fluctuation in the voltage at this moment. So I have built within a couple of hours a complete IoT solution. And that is based on Fabric. So my customer or the user can do self-service data investigation on top of the data that's coming in. So, well, that was the demo. And now it's up to you. There's a call for action. If you're interested in Microsoft Fabric or in the real-time analytics part, there are free training modules available in Microsoft Learn. And there's even a free trial available for you to use for Microsoft Fabric if you don't have one at this moment. And if you really want to put the cherry on the cake, why not go for a certificate and try to get that Fabric and Analytics Engineer Associate certificate. If you look at the training path, these are part of the Microsoft Learn Cloud Skills Challenge. And if you complete that challenge within the next 30 days, you get 50% off the cost of the exam. So, well, that's really nice. And of course, last but not least, I have written a number of blog posts about what you've seen here and many more stuff which is IoT related. So With that, thank you for your attention. And yes, Richard, again, thank you for having me.